This is a picture of Jeanne Calment at the age of 22 in 1897. She was born in 1876, the same year as the Battle of the Little Bighorn that saw the U.S. Army defeated by Native American tribes on the western frontier. The next year of her life saw a samurai revolt against the Japanese government, and by the time she was 39, Archduke Franz Ferdinand had been assassinated, sparking the First World War. By the time she was 114, she witnessed the collapse of the Berlin Wall, and by the time of her death in 1997 at the age of 122 years, she achieved the longest lifespan of a human ever recorded. Everybody has dreamt at some point of living a long life or even an infinite life, and science has helped with this through the last century with inventions like vaccines and antibiotics. These have helped to dramatically raise humanity's life expectancy at birth across the world, like in the United States, where between 1900 and 2010, life expectancy increased from just 47.3 years up to 78.7 years. But further improvements in life expectancy have been slowing lately as medicine has struggled to find cures for more complicated diseases. Because of overdoses, alcoholism, suicide, and the opioid crisis, 2016 was the first year since 1993 that saw a decline in the American life expectancy. Even still, life expectancy in the long run is still increasing around the world, and it's unknown currently how far the limit can be pushed. Scientists in search of increasing human lifespan point to other organisms with dramatically longer lifespans than our own, like some giant tortoises that can reach near 200 years, and some small freshwater animals of the genus Hydra that appear not to age at all. One study from the Albert Einstein College of Medicine suggested that 125 years is the maximum age limit that a human could ever reach, while other scientists like Aubrey de Grey believe the limit could be pushed much further, up to even 1,000 years. All of these claims have been met with a fair amount of skepticism, so it seems that nobody really knows just how far human lifespan can be pushed. Because of this uncertainty, what's become much more important lately to many scientists instead is focusing on an individual's health span, the part of your life where you're healthy. There is data that suggests that most people alive now would be content with having the current expected lifespan, but with an improved health span. Because chronic diseases become more common the older you get, increasing a person's lifespan alone likely won't do much to increase their quality of life. Instead, improving an individual's health span will add much more value to their life. There are already several different products on the market right now targeting different biological pathways that scientists are researching to determine if they can support health span. It's important to understand, however, that all of this is new research and that these products are not interchangeable. With that being said, one of these products is metformin, an FDA-approved drug that treats type 2 diabetes. When used in trials on mice and roundworms, the drug improved both their health spans and lifespans, and it's currently undergoing human trials. But other ways supporting health span may not require medication at all, though. There are three interesting areas of research to highlight here. First, a recent study found that when mice were allowed to eat only at certain times during the day, their metabolisms became healthier. When this fasting diet was applied to humans who only consumed between 700 to 1100 calories for a period of time each month, it lowered blood pressure and reduced the hormone IGF-1, which is linked to both aging and disease. There's also the technology behind genome editing with CRISPR-Cas9, which is essentially capable of turning good genes on and bad ones off. If your genes are like a school essay assignment, then CRISPR-Cas9 is like the spell check that can edit and correct them. This technology could specifically target genes that are associated with aging. Finally, another method and hot topic for research is by improving NAD levels later in your life. NAD is a coenzyme inside every cell of your body, which scientists believe is one of the most important factors for DNA health, energy creation, circadian rhythm regulation, and hundreds of other vital functions. They can be found in every living cell, but as you get older, your levels naturally begin to decline further and further. There are many preclinical and human trials being planned right now for the NAD pathway, but in order to try improving health span in the future, we'll need trials for additional methods as well. We don't know how far the limits are right now, but I think that's a cause for optimism because the answer might only be limited by our imagination.